Hello my dear students, and welcome all of you to the science tutorial of standard 10. So students, we are going to start with unit 3 of our textbook, and from unit 3 we are going to start with lesson number 10, that is reflection and refraction of light. The weightage for the unit is 12 marks. I know everybody is aiming for scoring more than 90% in the exam. But I really want that everybody's objective should be to understand the concepts in detail. Just scoring marks should not be our objective. So our lesson, reflection and refraction of light. You must be wondering that the words are pretty much familiar. We have already learned this in lower classes. Yes, you have done it, but that is very basic level. In standard 10, we are going to learn about reflection and refraction in detail. We are going to learn about how images are formed when we talk about reflection and refraction of light. Children, I personally always feel that light is a mysterious term or concept in physics. You know, all the beautiful phenomena which we observe in nature, like say twinkling of star or formation of beautiful rainbow, or the beautiful colors when we see at the time of sunset and sunrise, it is all because of light. You must have heard certain terms like say invisibility or theory of relativity or time machine. These are all the terms which are associated with light. And definitely the beauty of this optics you are going to learn when you go in your higher classes. So I feel that all the future discoveries in the field of science or the discoveries in the field of physics are deeply rooted into this beautiful branch of physics, and that is optics. But coming back to what we have in standard 10, light, when we say light, it is the form of energy and it enables us to see. When light travels from sun towards the earth, you know that sun is a major source of light and we get light from sun. So when light travels from sun and it reaches to earth, it takes 8 minutes and 20 seconds to reach to earth. When this light travels from sun to earth, it travels with the speed of 3 into 10 raised to 8 meter per second. So I can say that speed of light in vacuum or speed of light in air is 3 into 10 raised to 8 meter per second. Now let's begin with understanding certain say properties of light. The first property is light is an electromagnetic wave and it doesn't require medium to travel. Now let's understand the first thing. Light is an electromagnetic wave. When I say the word electromagnetic, it is made up of two words, electric and magnetic. So, meaning is that the electric and magnetic field, they are coupled together, they are mutually perpendicular to each other, and they propagate in the forward direction in the form of a light wave. And so we can say that light is an electromagnetic wave. So this is the new learning for you children. You are only aware that light travels in the form of a wave. But which form of wave is this? It is electromagnetic wave. Now this second property of light is very well known to all of you. You have been learning this since your lower classes. You all know that light tends to travel in a straight line. So that's the property which you all are already aware. After this, we will be learning about the new and an interesting property of light, and that is light has dual nature. So this is something new for you. When I say light has dual nature, meaning of dual is two types. Up till now, you know that light travels in the form of a wave. So the new learning for you is that light can also travel in the form of a particle. Meaning is that light has dual nature. It can travel in the form of a particle or it can travel in the form of a wave. And this understanding we will see through a small animation now. In 19th century, the great physicist Albert Einstein proposed a wonderful theory. He discovered that light travels in the form of a particle or it travels in the form of a wave. And for this wonderful discovery, Albert Einstein was awarded with Nobel Prize. So far, several experiments have confirmed that light is indeed in the form of a wave or it is in the form of a particle. Up till now, all the experiments which have been performed have proved that light travels either in the form of a particle or it travels in the form of a wave. None of the experiments have proved that light travels in the form of a particle and the wave at the same time. So, all the scientists across the world are eager to discover this dual nature of light. They want to see light traveling in the form of a wave and particle at the same time. And this is the reason, children, since it travels in the form of a particle and in the form of a wave, it is said to have dual nature. You must have all heard about photoelectric effect. In photoelectric effect, light is in the form of a particle. But when you come to the visible light, this visible light is in the form of a wave. And the discovery of light wherein it can travel in the form of a particle and the wave at the same time is still pending. Next property is when light falls on surface, it shows two phenomena, reflection and refraction. So see the first figure, children, that when light falls on any of the surface, it is reflected back into the same medium, and this phenomena is called as reflection of light. Now you see the other adjacent figure, you can observe that when light travels from one transparent medium to other transparent medium, at the point where both the media interact with each other, which is called as interface, at that point light is changing its direction. You will observe that now light doesn't travel in the same line, it has changed its direction, and when light comes out from one medium to other medium, even during that time also, it is changing its direction. So this change of direction of light from when it travels from one transparent medium to other transparent medium is called as the phenomena of refraction of light. In this session, actually we are going to discuss first only with the first phenomena, that is reflection of light. So let's first understand, or I must say that let's first revise the laws of reflection of light which you have already studied in your previous class. So we'll see this with a small video. So we have taken a plain mirror and the reflecting surface of the mirror is XY, which you can see, and the polished surface is below that. So from a light source, an incident ray is incident on the plane mirror, and that ray is reflected as ray OB. ON is a normal which is drawn at the point of interface. Angle AON is angle of incidence, and angle BON is angle of reflection. So from this, the observation of this activity is that the incident ray, the reflected ray, and the normal drawn to the reflecting surface at the point of incidence all lie in the same plane, and angle of incidence is always equal to angle of reflection, and this is called as laws of reflection of light. Now when we talk about reflection or refraction of light, it is always associated with formation of image. So what is image? It is a point where at least two light rays actually meet or appear to meet. So images are of two types. First type is real image. Now what is the meaning of real image? Just see there. You can see that the object is a candle there, and from the candle two rays are actually meeting at a pinhole, and the inverted image image is formed on the screen. So I must say that real images are formed when light rays actually meet at one point. Real images can be obtained on the screen, and these are inverted images. The second type of the image is virtual image, and the meaning of virtual image is it is formed when rays of light appears to meet, and such type of images cannot be seen on the screen. Now see there on the screen, children, that a plane mirror is kept, and towards the left side of the plane mirror an object is placed. So when light falls on this object, from the object light is first reflected on the plane mirror, and from the plane mirror it is reflected into the eye of the observer. So the observer perceives that the image of the object is formed behind the mirror, and suppose if I extend the rays of light, it appears that the rays of the light appear to meet at one point, and there the image is formed. Such type of image is a virtual image, and the property of this image is that these images cannot be formed on the screen, and these are always erect images. Children, when you look yourself into the mirror which are there at home, you see your exact image into the mirror. Such mirror is a plane mirror. But have you ever visited a laughing gallery? In the laughing gallery, when you entered inside, you see your image as a funny image. Sometimes you see yourself to be very fat. In some mirrors it's showing you're very tall. In some mirrors your image is distorted. Different types of funny images you see there, and you get a chance to smile, you get a chance to laugh. But have you ever thought why it is happening like this? The reason behind this is that the mirrors in the laughing gallery, they are not plane mirrors. At the edge of the mirror is slightly curved, and such mirrors are called as spherical mirror. I'll just give you some example from the daily things which we use. Say children, you are very hungry and you are waiting for your food, you are on the dining table. What do? You try to play around with the spoon. You hold the spoon in your hand, you look yourself into the spoon, and you see your image into that. Then when you take the spoon away from your face, you realize that now your image is inverted. Oh, then you try to bring the spoon near to your face. You realize that now your image is magnified. And again you get a chance to smile. Children, this spoon also acts as a spherical mirror. So any mirror which has a curve inward and curve outward, acts as a spherical mirror. But now the question is, how the spherical mirrors are formed? How do they look like? What is the procedure to make a spherical mirror? That we will understand from the next video. Imagine children that you have a sphere which is made up of glass. Just observe there, a sphere of glass of any thickness. Now if I cut this sphere into two parts, I can see one part like this. Just observe there, one part of the sphere look like this. One surface is curved inward and one surface is curved outward. Now suppose if I polished the outward surface, then the inner surface acts as a reflecting surface. And suppose if I polish the inner surface, then the outer surface acts as a reflecting surface. And based on this, we can say that spherical mirrors are of two types. Now, when we polished the outer surface of the mirror and the inner surface is reflecting surface, that spherical mirror is called as concave mirror. See there towards the left side. And when the inner surface is polished and the outer surface acts like the reflecting surface, that mirror is called as convex mirror. Now let's understand different parts of spherical mirror. Pole of the spherical mirror. The center of reflecting surface of the spherical mirror is called as pole. You can watch there in the slide. P stand for pole of the mirror. Center of curvature, concave and convex mirror is drawn on the slide. Imagine that this concave and convex mirror is a part of the whole sphere. Then the center of the sphere of which the reflecting surface is a part is called as center of curvature, and it is represented by letter capital C. Remember one thing, children, that center of curvature is not the part of the mirror. It is always present outside the spherical mirror. So in both the diagrams of concave and convex mirror, you see that center of curvature is at the center, which is outside the mirror. Next is the radius of the curvature. Now radius of curvature, it is the radius of the sphere of which the reflecting surface of the spherical mirror is a part. It is represented by the letter R. The next is principal axis. So principal axis is an imaginary line which passes through center of curvature and the pole of the mirror. Remember one thing, that principal axis is always perpendicular to the pole of the spherical mirror. Next is principal focus. Now when the rays of light are incident parallel to the spherical mirror, after reflection, the rays either converge at one place, or in case of convex mirror, after reflection they diverge, but they appear to emerge from one point on the principal axis. That point is called as focus of or principal focus of the spherical mirror. You can observe that both in case of concave mirror and convex mirror, principal focus is denoted by letter capital F. In case of concave mirror, it is towards the reflecting side of the mirror, and in case of convex mirror, it is on the opposite side of the reflecting surface. Now keep one thing in mind, children, that in case of a concave mirror, when the rays of light are incident on the concave part, after reflection they converge at one place. That place is principal focus, and so concave mirror is called as converging mirror, and convex mirror, after reflection the rays of light they diverge, and it appears that they are emerging from one point, that's the focus. Since the rays of light diverge after reflection, convex mirror is called as diverging mirror. Next is focal length, and focal length is the distance between the pole and the principal focus of the spherical mirror. So it is denoted by letter small f. We have a relation between principal focus and radius of curvature, that the focal length is always half of the radius of curvature. So I hope all the parts of the spherical mirror is clear. You will be able to identify each part of the spherical mirror. Okay, our next topic is rules to draw the image formed by concave mirror. There are 4 rules, children, and these rules are very important to find out where the image of an object is formed. So our first rule is, when the ray of light is incident parallel to principal axis, after reflection it will always pass from focus F. In case of convex mirror, when the ray of light is incident parallel to principal axis, after reflection it diverges, but it appears as if it is coming out from focus F. Second rule is that when the ray of light passes through focus F, after reflection it is always parallel to principal axis. This is in case of concave mirror. In case of convex mirror, when the ray of light is directed towards focus F, it's not actually passing, children, it is directed towards focus F.
After reflection, it is always parallel to principal axis. Third rule is, when the ray of light passes through the center of curvature, in case of concave mirror, after reflection, it retraces the same path. And in case of convex mirror, when the ray of light is directed towards center of curvature, after reflection, it also retraces the same path. The fourth and the final rule is that when the ray of light is incident directly on the pole in case of both the mirrors, you will observe that it always obeys the laws of reflection of light. So the angle of incidence and angle of reflection in both the cases will always remain the same. These are the four rules which we have to keep in mind, and out of these four rules we can make use of any two types of rays to draw the image formed by concave mirror. So when we will go to that particular topic, we will exactly find out as to how the image is formed because of the concave mirror.
So I hope children today's discussion is fruitful and you must have understood the concepts, and I hope all the concepts were really very easy, and these were the basic concepts related with light. And based on today's discussion, I have made a small assignment for all of you. So I want all of you to make a separate notebook and try to write down all the questions which are written over there. I have given 5 questions to all of you. Please write down the question and get back to me if you have any difficulty. So that's all for today's session. See you all in the next lecture.